Yes. Hi, everyone. Yes, I'm Florian Bömers. I run my own software and hardware company called Böhm Software. And I'm also a member of the MIDI Association, where I'm a member of the Technical Standards Board and the chair of the Transport Working Group, where we are currently developing the network MIDI 2.0 transport for MIDI. I apologize in advance for my voice and for anything that can happen because I have a very bad cold today. And well, I hope this will go fine anyway. So just a very quick recap of what MIDI 2.0 is. It consists of two big areas. One area is MIDI CI, which really is an extension of MIDI 1.0, allowing you to discover other devices that implement MIDI CI, exchange properties back and forth, information about the device using the so-called property exchange. And it has a system called profiles, where you can enable and disable higher level functionality. And we'll see more of that a little later. And the second big part of MIDI 2.0 is the universal MIDI packet, which is really the new protocol that you would associate with MIDI 2.0. It uses 32-bit based messages, so it's a container format. All values in UMP are 16-bit or 32-bit. In addition to the 16 channels in MIDI 2.0, it consistently provides 16 groups, so you can have much more channels. It provides simple timestamping called JR timestamps, JR for jitter reduction. And it contains all MIDI 1.0 messages in plain MIDI 1.0 form. So it's very easy to transform a MIDI 1.0 implementation to UMP because it contains all MIDI 1.0. And then later on, you can transform your implementation to the MIDI 2.0 protocol, which is all of MIDI 1.0, but with higher resolution. You have more controllers, and there are also new features, for example, per note controllers and per note pitch bend. You have note articulation, so when you hit a note, you can also specify how that note is hit. For example, for a string instrument, you can say this is now pizzicato, or it's a legato or a staccato note. And also one thing that is really different from MIDI 1.0 protocol is that MIDI 2.0 is built up from the ground to be extensible. So we will probably see a lot of extensions in the future. And also MIDI 1.0 and MIDI 2.0 can be translated back and forth with their resolution. So it is relatively nice to have that translation for having MIDI 1.0, MIDI 2 devices living next to each other and communicating. So the current status of MIDI 2.0 is mainly defined by the work of the MIDI Association, which creates and releases the standards. In 2020, the first MIDI 2.0 specifications were released. And that was followed by a period of mainly prototyping and testing. A lot of companies have started using MIDI 2.0 in-house and well, just trying how it works. And in 2023, in June this year, the MIDI Association released a few more specifications and updated it some. I will go into that in a minute. And for 2024, we expect MIDI 2.0 to really grow and where we will see actual devices from major companies. So we'll have more and more of a real MIDI 2.0 ecosystem. And remember, all that is interchangeable with devices running MIDI 2.0. So all your MIDI 1.0 gear will not be outdated. You can always use it in conjunction with MIDI 2.0 gear. So this year, a couple of specifications were updated. The MIDI CI specification is now in version 1.2. We deprecated protocol negotiation, and that was moved to UMP, and also added a couple of new features, process inquiry, some more profile messages, and function blocks. I will not go into any details here, but just so that you know, you should use the new version if you're not using it already. Also, profiles were extended with a couple of missing messages, so profiles are much more useful now. And the UMP specification was also updated. That was actually more of a major update. For example, there are now groupless messages that sort of apply to the entire device. You could think, for example, timing messages are better suited for the entire device and not on a specific group. And we've also added UMP endpoint discovery and protocol selection, because that's now, that was moved from MIDI CI to UMP. And also a lot of new messages, including a whole set of meta events that you would previously find in MIDI files. The standard MIDI file defined meta events like tempo, song text, and stuff like that. And we've also added all that to UMP, so that MIDI 2 files will just be a series of UMP and no specific meta events. Yeah. And in 2023, the MIDI Association has also released new specifications. The MIDI clip file specification. It's a standard MIDI file format for UMP. It doesn't have the MIDI container file format yet, but this is coming hopefully soon. We've also released the so-called MIDI 2.0 bit scaling and resolution specification. This is more of a collection of guidelines for how to scale values, because when you're dealing with MIDI 1.0, it's mainly 7-bit, sometimes 14-bit data. In UMP and MIDI 2.0 protocol, you have a lot of 16-bit, 32-bit data, and you need to scale that somehow. If you receive data from a MIDI 1.0 device, say 7-bit velocity, you want to scale that up for 16-bit in UMP. And also your internal resolution of your device might even be different. So there are guidelines for scaling and for how to use different resolutions. And I recommend everyone who's doing any of that to read that document. It's really helpful for developers. And in 2023, we've also released the Property Exchange Controller Resources specification, which allows you via MIDI CI to receive a list of controllers from a device and which controllers are in which channels, and a controller map list. So there's a lot of information you can get now from a device regarding controllers in a standardized way. So I think that will lead to great applications in DAWs, for example. Speaking of DAWs, MIDI 2.0 is already implemented in Logic Pro and in Multitrack Studio, and we expect other DAWs to implement MIDI 2.0 soon. Of course, they have to speak for themselves for any more concrete details on that. For MIDI 2.0 to be successful, obviously we need operating system support. These four major operating system manufacturers have announced or have already released MIDI 2.0 support. Apple, Google, Linux, and Windows. And I'll go into more detail. On Apple, they were the first, already a couple of years ago, they implemented MIDI 2.0 in macOS, iOS, and iPad OS. And every new version of their operating system saw great improvements from MIDI 2.0. They have a USB MIDI 2 driver and transparent handling of MIDI 1 and MIDI 2 devices, also of software. So the API, you can talk UMP or you can talk MIDI 1.0 and it's all interoperable. So if your software is still using MIDI 1.0, it'll work just the same with MIDI 2.0 devices, but also with MIDI 2.0 software and vice versa. So this is really great to see all that MIDI 2.0 support in the Apple operating systems. Apple also provides a MIDI CI SDK, so you can easily implement your own property exchange and profile mechanisms. Regarding Android, I've received a video from Robert Wu at Google, so let's have a look at that.
Hi, I'm Robert. Along with my colleague Philbert, we added MIDI 2.0 on Android. Android has been supporting MIDI for a while now, ever since Android 13, we added support for MIDI 2.0. Perhaps to use MIDI 2.0, all you need to do is make a few changes. We define two transports, the MIDI 1.0 bytestream transport and the transport for universal MIDI packets, the UMP transport. Before, to get a list of devices, you called MIDI manager.getDevices. Now, you can specify transport with MIDI manager.getDevices for transport and put in transport, maybe the UMP transport per se. To register for callback when devices are added or removed, you would call MIDI manager.registerDevice callback and specify a callback. Now you can also specify transport. For example, the UMP transport. We have samples at github.com/android/MIDI-samples. If you have any questions, feel free to email me at robertwu@google.com. Thank you.
Thanks, Robert, for that. And at the end, I will provide some links where you can get more information on the individual operating system APIs. Linux, we've seen recently great work by Takashi Iwai, who works at SUSE Linux. He has implemented MIDI 2.0 USB driver and sequencer package which is now part of Linux kernel 6.5. And that was also closely developed with the MIDI Association. And in kernel 6.6, the most recent, I think, he also added support for the USB MIDI 2.0 gadget driver, which allows a USB client or a USB device to connect to a different device, most useful on Android, on Linux devices that want to connect a MIDI 2.0 USB device. The main interesting part for developers is the extension of the existing also sequencer API, which is now fully UMP capable. Apps can connect to MIDI 1.0 and MIDI 2.2 devices arbitrarily, similar as on Apple. All data conversion is performed automatically and transparently. So if you're using sort of the old sequencer API using MIDI 1.0 messages, you can still talk to a different component on the computer or a MIDI 2.0 device running the MIDI 2.0 profile, and it's all converted automatically. So because this is really new, I wanted to show you some examples how this works. opening the sequencer instance is the same as with MIDI 1.0, but then there is a new function, set client MIDI version, where you set the version to MIDI 2.0. And for sending UMP messages, it is similar to how you would do that with MIDI 1.0, but instead of constructing a MIDI 1.0 event, this is now a UMP event. So there's a lot of setting up of the event from your raw UMP data, and then setting source and destination, and eventually in the last line, sending that event to the sequencer instance that you have previously opened. Receiving UMP is also very similar to how it works with MIDI 1.0 instead, but of course you have to allocate a UMP event again and receive it from there. So once you have your UMP stack running internally, it shouldn't be hard to make it compatible with Linux. On Windows, we haven't seen any public API yet, but we know that there's a lot of work being done at Microsoft, and Pete Brown had sent me this video, so I'm very glad to show it to you.
Thanks, Florian. Hi, everybody. My name is Pete Brown from Microsoft, and I'm also the Executive Board Chair of the MIDI Association. And today I want to give you an update on where we are with Windows MIDI services, which is our complete rewrite of MIDI on Windows and including MIDI 2.0. So this is an entirely new stack, as I've said before, and we're trying to hit as many of the community wish list items as we possibly can during this. For one, it has a much faster underlying architecture for actually transferring messages back and forth. So there's lower jitter, much lower latency. I know performance has been a concern for many over time here, so I'm hoping that kind of ticks all the boxes. We have a new MIDI 2.0 and 1.0 class driver, which again supports both of those. We have things like device renaming, portable JSON configuration files for all your MIDI settings, including things like names. We have time-stamped and scheduled messages, so when you want to guarantee that messages go out at a certain time, we now have that support through the service. We have richer enumeration support with many more endpoint properties, so you no longer have to look for things just based on, say, the name of the endpoint or name of the device. We provide a lot more metadata along with that. We also have Sorry about that. We also have COM plugins for transports, so no need to create drivers in most cases. We're implementing the Network MIDI 2.0 specification transport that way. We've implemented virtual MIDI that way. We're going to be implementing a clean version of Bluetooth MIDI 1.0 out in the open with hopefully all the bugs fixed that have been reported to us over time, so that we can have that as fully open source with the rest of Windows MIDI services. We also have support for COM plugins for message manipulating in the service. So doing things like translation, handling and caching metadata, and much more. And that's also an open API available to anybody who wants to author to that. So everything in this new API is presented as UMP, regardless of the type of device that it's connected to. And we do all the translation and everything that's required behind the scenes. And then it works on the latest version, I should say, supported versions of Windows 10 and Windows 11. So we also have here plenty of help and documentation as part of our repo. We're adding a lot more. I say plenty, it's enough to get you started right now. And of course, we'll have full documentation through our regular Microsoft Learn site afterwards. We have information on all the different types that you will be working with as part of the API. And then we also have example applications, which is really kind of where we're focused right now, that make it simple for you to figure out how to use a new API, kind of what are the best practices and more. And we're doing this all in the open, like I said. We've also have a Discord server which you can find the link at our repo at aka.ms whack MIDI repo. I've been answering questions on there. We've been discussing different features that developers and customers want. For example, we've also been announcing new things and getting feedback on them when they come out. An example here you see is when message scheduling was recently put into the service. We got some good feedback on that, and folks are really interested in that as well. Let me minimize that. We also, like I mentioned, have the samples and stuff here, but I think probably one of the best things that we can do is show you some examples of how the API works. Now, we ship 2 applications as part of this. One is the MIDI settings application, which is definitely, it's a GUI application that's more end user focused and provides access to all the stuff in the MIDI system, so you can do all your renaming of devices and move your configuration files and save those routes and create virtual devices and all those types of things. But in addition to that, we have a command line tool, which is for more technical folks, and it's also really good for developers to use to be able to test different aspects of the MIDI system, or test your own implementations by communicating with your applications and communicating with your devices. I believe I mentioned that the new API is all multi-client, all the way through. So we can have a couple of different windows open here doing different things in the console. So first, let me show you, if we just type MIDI, we get the console up here. And I can say like MIDI service status verbose, and it's going to give me information about the Windows service that's backing Windows MIDI services. I can also say MIDI enumerate endpoints, and in this case I'm going to include the built-in loopback endpoints that are shipping with this, and that lists all the different endpoints that are available to us. I mentioned the loopback endpoints. These are always available whenever the service is installed and running, so that you as a developer can test without having a MIDI 2.0 device. These are full UMP endpoints that are cross-connected, so anything you send out on A comes in on B, anything you send out on B comes in on A. You can also do, I think probably one of the more useful things, I could say MIDI endpoint monitor verbose, because we want to actually see the messages as they come in. And I'm going to listen on loopback B. And then I can go back over here to the other window, and I can say, let's see, MIDI endpoint send message, and I'm going to give it a valid UMP message, at least as much as the message type goes, so it knows how many words are in that message. I'm going to say 309, right? And I'm going to sound 10 of those, right? So 75309, yep. And it's going to prompt me as to which endpoint, and you can see over here that those came through. Again, I mentioned all the messages are timestamped, and it can also tell me like what the offset was and everything here, the group and channel, etc. Now, we also have support for message scheduling I'd mentioned. So instead of sending 10 messages here, if I want to send, let's see, 3, 2, 6, 3, 8, 2, 7, and if I want to just send this over and I want it to be scheduled for a few seconds into the future, I can give it an offset, and that offset here is going to be in microseconds. So I can say 2 seconds into the future. And I'm going to send that to A, and in 2 seconds, you'll see the message pop up over here, and there it is. And then, I can run my unit tests against this, and so if I pull up, here's my console with the unit tests on it, I can run that, and you can see here are messages coming through, and it's displaying all of those there. The messages themselves aren't valid, but again, in this case, as long as the message type is valid, we're good, because we don't eliminate things here, because we want to make sure that it's possible for you to prototype new messages, prototype new transports, do a bunch of stuff like that in there. Also, now finally for older apps, we will have shims which point to the existing WinRT MIDI 1.0 APIs and the WinMM MIDI 1.0 APIs to the new Windows service. Those are not in place yet, but they will be coming soon. And the intent there is to make sure that they can access all the devices that are connected at a MIDI 1.0 level of our feature level for those. So, for example, you wouldn't be able to send stream messages through those APIs, but you would be able to do all the normal interaction that you would do with a device today, whether that device is MIDI 1.0 or MIDI 2.0. We take care of the translation behind the scenes, so the existing APIs remain 100% compatible with what you have today, but they're just repointed to the service behind the scenes there. We also had hardware partners up in Redmond in October to test their MIDI 2.0 devices with the full stack here. Everything there went well. We were really excited to see some prototype and soon to be shipping MIDI 2.0 hardware actually talking through this full stack and able to use the new API and have their messages show up here just like some of these endpoints. So Developer Preview 2 will be out soon. We're working on the best preview distribution method to make it so that it's easy for another developer to be able to install the class driver. There are additional hurdles that you have to go through in Windows to install a class driver. You can't just build the driver yourself and have it show up as a class driver. You can build a vendor-specific driver, but not a class driver. So we need to do some signing internally and get that out as part of that. And we'll package that all up with the API, the Windows service, and the tools so that you can use this as developers and start building applications against this before we ship in-box in any of the preview builds of Windows. Speaking of which, I mentioned that we're supporting any of the currently supported versions, at shipping time, any of the supported versions of Windows 10 and Windows 11, and we will ship in-box for Windows 11 and I believe Windows 10 in 2024, so that's coming up fairly soon. And with that, thank you very much. I really appreciate your time here today. If you want to learn more, please go to aka.ms WAC MIDI repo, and that will get you to the repo, and the Discord link is also on that main README. Thanks.
Thanks, Pete, for all that information. I think for many MIDI developers on Windows, that will be a dream come true, at least for me. To see all these enhancements, multi-client, virtual drivers, and a lot of good stuff coming up in Windows. Next, I want to talk a little bit about developer resources, or actually start off with Mike Kent, who's working at Aminode, and he will talk a little bit about what the MIDI Association is providing for developers.
Hello, my name is Mike Kent, and I'm chairman of the MIDI 2.0 working group. The MIDI Association has resources for developers to learn about MIDI 2.0 and to implement into their products. We intend to increase that support for developers. MIDI Association members can join weekly developer support working group meetings to ask questions and get technical support. The MIDI Association also has development tools, including the MIDI 2 Workbench software and the Omnote Protozoa hardware. The Workbench software, the MIDI 2.0 Workbench, is Mac, Windows, or Linux application that allows debugging of MIDI 2.0 products, testing of many MIDI functions, and it also verifies compliance for licensing the new MIDI logo. The Protozoa from Omnote is a MIDI 2.0 hardware testing and prototyping platform based on a Raspberry Pico. The Protozoa acts as a USB MIDI 2.0 device, and the source code for that USB MIDI 2.0 is provided as open source. The Protozoa works very closely with the MIDI 2.0 Workbench software. The MIDI Association is increasing its support for all developers with new articles being published on MIDI.org. We also have a developers discussion forum at MIDI.org. At the next NAMM show in January 2024, the MIDI Association will host a developers conference, both live and online. MIDI Association members are also releasing open source libraries to help other developers join in bringing MIDI 2.0 to their customers. The AM MIDI 2 library is a C++ library for devices and applications, and that can be found at MIDI2.dev. The NI MIDI 2 library is also C++ library for many functions, and is provided by Franz Dietrich of Native Instruments, also at MIDI2.dev. Böhm software provides a library called Böhm MIDI 2, which can be found on their GitHub. Also on MIDI2.dev, you can find the tiny USB MIDI 2.0 plus 1.0 library that's used in the protozoa, provided here as open source by Ominote. In the Linux kernel version 6.6, you can find the Linux MIDI 2.0 gadget, which provides USB MIDI 2.0 functionality for embedded Linux devices. The USB descriptor builder here generates device descriptors for a USB MIDI 1.0 and MIDI 2.0 device. In addition to the descriptors, it also generates the constants which are used in the tiny USB MIDI library from the protozoa, as well as properties for the Linux MIDI 2.0 gadget.
All right. Thank you, Mike, for that video. And also for developers, especially here, very important is Juice support. Just recently, 2 weeks ago, MIDI CI made it into Juice. There's now a module, Juice MIDI CI, which provides discovery, profiles, and property exchange. And there's also a demo app. So it's very easy now as a Juice developer to make your app MIDI CI compatible, and implementing that will also make it a true MIDI 2.0 device, because the rules are if you implement at least 2 MIDI CI features, you can already say it's a MIDI 2 device. So you can add UMP support later, but MIDI CI already qualifies as a MIDI 2 device. So what's coming up? The MIDI Association is still very busy developing new specifications. In particular, there are a lot of profiles being worked on. So the general idea, as said, is to enable and disable certain features. Those features are then well defined. So once that specific feature is enabled, you know exactly what responds to controllers or what the velocity curve is. You know, a profile can specify a lot of things that will then just work and be interoperable once the profile is enabled. It is using MIDI CI, so it's MIDI 1.0 protocol. But of course, will also run on UMP. The only currently ratified profile is the default control change mapping. It's a useful but very simple profile. Once enabled, it means that all the standard MIDI 1.0 controllers have their standard meaning, like reverb or volume control. And if you don't enable that, you just don't know if a device is responding to the default MIDI 1.0 controllers. So there are profiles that are being worked on. So of course, anything here is subject to change because it's still in progress and not ratified yet. But there is the MPE profile coming up, which mainly means that once enabled, you know that the other device you're talking to has MPE or is MPE compatible, and will and once activated the profile, the device is in MPE mode. so you know what to expect. It also has provisions how to use MPE in a MIDI 2 environment, so that's going to be very useful. The piano profile is mainly for acoustic piano that are MIDified, and there's the rotary effect profile for, well, rotary effects like Leslie, I think. The drawbar organ profile, again, is very useful because once activated, you know that the other device is compliant with that profile, meaning that all controllers have a predefined meaning, so which drawbar responds to which controller. So will make it much easier to have a interoperable environment for devices, like in this case, a drawbar organ. And there are other profiles. The orchestral articulation profile, or the orchestral ape, as we call it, defines node-on articulation articulations for orchestral use. So you can define exactly what the node-on articulation will mean for a specific instrument. So again, as I've given that example with a string instrument, the orchestral articulation profile will say exactly which articulation number will correspond to which articulation type, like staccato or legato. So once that profile is available and a device or maybe a software synthesizer implements it, you can enable it. And from then on, you can use all those different articulations in that synthesizer in an interoperable way. You don't need to map anything or choose different voices only because you want to use a different articulation. So it's all in the node-on now and interoperable. Then there are two GM2 profiles for a general MIDI 2. This is for like older style general MIDI synthesizers. There's one profile that acts on an entire function block, which is sort of a collection or one or more groups, MIDI 2.0 groups. And there's also a single channel profile, so you can enable and disable general MIDI on a given MIDI channel, MIDI 2 channel, or MIDI 1 channel 2. So these are simple profiles, but very useful if you're using general MIDI. The last profile here on this list is sort of a special one. It controls cameras. So via MIDI, so you can control the rotation up and down and zoom. And already a couple of cameras apparently use MIDI to control them, but there is no standard. So using this profile, you can first of all find out that a device supports the camera control profile and then activate it. And then again, you have an interoperable way to control that camera no matter which manufacturer. The last section of this presentation today is about transports. Of course, MIDI has to be transported somehow. You want to send your MIDI messages from A to B. In MIDI 1.0, it started off with a MIDI DIN transport, but then USB is also widely used for MIDI 1.0. There's RTP MIDI for networks, and a lot of other MIDI 1.0 transports. Then for MIDI 2.0, or more precisely for UMP, there's the USB MIDI 2.0 class ratified in the USB IF. So this is a standard already out there for a couple of years. And as we've seen, the major operating systems have or will support that. So all that is missing is devices that you can actually plug in with providing USB MIDI 2.0, but I hope we'll see that soon too. There's a lot of demand for some kind of MIDI DIN, but for MIDI 2 at higher speeds, hopefully bidirectional and a smaller plug, but and there are people in the MIDI Association working on that, but this is not really something that we can promise. However, the network MIDI 2.0 standard is progressing nicely. And here are some details about that. And all of this is, again, not ratified yet, so subject to change. But I'm positive that it will not change much. We'll see. Anyway, so the current state is that the first version of the network MIDI 2.0 specification will only target Ethernet and wireless LAN, so not suitable or not meant for internet use. And it only uses UDP. So we try to simplify matters to come out with the specification sooner rather than later, and then have a lot of features. So keep it simple. There are 3 main sections in the network MIDI 2.0 specification: discovery, session management, like session setup and teardown, and eventually, of course, data I/O, sending and receiving UMP messages. For discovery, we've decided to use the standard MDNS plus DNS SD. That's exactly the same as what is used by RTP MIDI on Apple. They call it Bonjour. This is a standard also known as zero-conf networking. So we're trying to use what is available without reinventing the wheel here. Also, all major operating systems provide MDNS services, so you can just use them and you don't need to implement it on your own. Once your device is discoverable via MDNS, you will provide your IP and port of your network MIDI 2.0 service, and then also your endpoint name, sort of the name of your device, of your synthesizer, and a so-called product instance ID, which can be seen like a serial number or a unique ID, sufficiently unique that you will not see the same in your studio. So with these data fields in the discovery, it is possible that you can re-identify a device on the network, even if it changes IP and port number, because you have the endpoint name and the product instance ID. It also makes it easy to have multiple endpoints on one device. You could give it a different name and maybe a different product instance ID, and then, you can have as many as you like. The entire discovery aspect of network MIDI 2.0 is optional. So if you have a special device where you just operate on IP and port, you can do that. You don't need to implement discovery. The session protocol mainly serves for setting up and tearing down connections from a client to a host. This one is newly developed. We use a very simple and clean header, and from then on, it's just a UDP packet containing session protocol commands. And this allows us to define authentication, because we don't want someone somewhere on the network to connect to your MIDI device and start playing on it, for example. I imagine in live situations that can be disastrous. Except for the no authentication case that is still possible, we recommend to at least for session setup, prompt the user, and only when he presses a button or clicks on a prompt on the screen or something, then the session will be set up and you're connected to each other. There are also password authentication mechanisms and username plus password. So, for example, for a school setting, you can have a number of name and password combinations that are valid, and they can connect to a certain device, MIDI 2.0 device, but only if you know the correct password. For sending and receiving UMP in the network MIDI 2.0 protocol, it uses the same structure as is used for the session commands. So it's just a UMP data command, and which means that, again, it's very efficient, very lean. You can have multiple UMP commands in one UDP packet, and you can also mix and match the session commands with UMP data. Makes it simple and allows for a lot of flexibility in the future. Network MIDI 2.0 also has mechanisms for data integrity. They're optional, but allows you to have like a retransmit if your underlying transport is not reliable, like wireless LAN might need that. So far, already 9 MIDI Association member companies have implemented the current state of the network MIDI 2.0 specification in our goal to test all features of the specification. And we're doing interoperability testing right now. So hopefully this means that we can ratify it rather soon, hopefully, probably in 2024. It can be implemented individually in your software, and you can use existing MDNS services by the operating system, but also the operating system can embed network MIDI 2.0, and then your software doesn't need to care about this at all. And it was announced in the session that I will also talk about the MIDI 2.0 logo program. So here it is. If you want to put that nice MIDI logo on your device or in your software, you need to acquire a license from the MIDI Association and sign a license agreement with them. It also requires self-certification. So you print out the results of your certification, and then the MIDI Association will believe you. But I think that's not on the slide, but I think it also requires that you're a member of the MIDI Association or pay a license fee. And that is the end of this presentation.
Yes.